Welcome back, everyone. I am super excited to have you here for another explainer. Today, we're unpacking a truly massive, literally ground-shifting transformation happening in the world of software development right now. We're drawing our insights from a fantastic piece over at DevOps.com that details the evolution from passive deterministic pipelines to self-healing agentic AI systems. Listen, if you've ever been tearing your hair out over a red pipeline blocking a critical release, well, you're going to want to stick around for this one.
Okay, real quick, here's our roadmap. We're going to kick things off with a daily frustration, the flaky test. Then, we'll define what agentic AI actually is, explore how it predicts and remediates failures, look at self-healing pipelines, and dive into multi-agent orchestration. Finally, we'll wrap up with the mindset shift you'll need to make all of this happen. Let's jump in.
Section 1. The flaky test problem. From annoyance to structural issue.
So we all know the flaky test, right? A random timeout, a weird race condition. Historically, a flaky test was just a minor annoyance. You just, rerun it, wait for it to go green, and completely forget about it. But as we start baking AI more deeply into our systems, this little annoyance is becoming a massive structural roadblock. Why? Well, old CI/CD systems rely entirely on strict binary assertions. They demand that X equals exactly Y. It's totally deterministic. But agentic AI, it doesn't really play by those rules. If you ask an AI model a question, it doesn't give you exactly Y every single time. It gives you a defensible, probabilistic Y-like answer. Run the exact same agent twice, and you might get two slightly different but completely valid results. Because of this, your traditional deterministic pipelines are structurally guaranteed to fail. They'll mark perfectly good logic as a broken test. You literally cannot use the old architecture to validate this new technology.
Section 2. Defining agentic AI. The shift to autonomy.
Before we go any further, we really need to explicitly clarify what resolves this structural failure. We toss the abbreviation AI around all the time, but I want you to ask yourself, what does the term agentic actually mean in a DevOps context? Like, how is an agent any different from the standard automated bash scripts we've been running for years?
Well, here's the definition we're working with from our source. Agentic AI is an automated system capable of receiving a target state, sensing its surroundings using telemetry and APIs, reasoning about the actions it should take, executing them, and then observing the outcome. And I really want to emphasize the word reasoning here. This isn't just a dumb script blindly following an if-then command. It's a reasoning entity making contextual decisions based on its environment.
This creates a continuous, intelligent loop. It gets the goal, senses the current reality, reasons out a path forward, and executes. And the crucial part, it observes the outcome and repeats the cycle continuously. It keeps going until the target state is reached or until it hits a strict boundary where it knows human intervention is required. Section 3. Prediction and autonomous remediation. Stopping failures before they happen. Okay, so how does this actually play out in the real world? It starts with stopping failures before they even happen. An agentic system looks at historical data, stuff like build times, flakiness percentages, resource usage patterns, to flag risks before a commit even triggers a build. Say an agent notices a specific microservice has an increasing P99 latency across the last 3 deploys, and wait, the test coverage for that service just dropped. The agent puts 2 and 2 together and infers a highly likely path to failure based on stat correlations way before you get a hard deterministic crash. And that right there perfectly illustrates the paradigm shift. Think about traditional monitoring. It's essentially a smoke alarm. It just yells at you that something is already broken and your users are likely already having a bad time. Agentic technology, however, warns you of an impending failure before it happens. You're shifting all that engineering effort entirely from reactive firefighting to proactive strengthening. And man, those benefits accumulate fast over time. But, things happen. Things slip through. Enter autonomous incident remediation. When an incident does happen, a fixer agent immediately jumps into the fray. It analyzes the logs, correlates the trace data, figures out the likely root cause, and then actively applies countermeasures. Assuming it has the right permissions, it can restart pods, roll back bad configs, redirect traffic, all without a human ever touching a keyboard or clicking a single button. Compare that to what we have now. Traditional AIOps discovers an anomaly and basically just writes a ticket for a human to read. Thanks, right? But an agentic AI system completes the diagnosis and actually applies the fix. Because they rely on the architectural principle of reversibility, meaning if a fix goes wrong, it can just instantly be undone, agents can safely execute high-confidence fixes on the fly.
We're talking about shrinking resolution times from hours down to literally just minutes.
Section 4, self-healing and adaptive security, active problem solving.
Let's bring this down to the everyday developer experience. We have all lived this absolute nightmare, getting woken up at 3 a.m. because the pipeline is red, you log in, and it turns out a front-end dev just updated a simple CSS class, the DOM changed, and now a dozen Selenium tests are failing because they can't find their visual elements. The core logic of the app is completely fine, but now human hours have to be wasted manually fixing brittle tests. Now, imagine how an agentic framework handles that exact 3 a.m. scenario. The test fails, but instead of waking you up, a repair agent takes over. It analyzes the new DOM, figures out the correct new element selector, updates the test code, reruns it to ensure it passes, and then just submits a PR with the fix. You wake up to a solved problem instead of a broken pipeline. That is the distinction between mere automation and true autonomy. It's absolutely a game changer.
And we're seeing this same autonomy tackle continuous security scanning too. The classic DevOps dilemma has always been that balancing act, right? Balancing deployment speed with thorough security scanning. If you scan aggressively, you slow everything down. If you skip scans, you leave yourself completely vulnerable.
Traditional static SAST tools rely on rigid, predefined rules, which usually results in a massive flood of false positives. But an adaptive security agent runs continuously and actually learns your unique codebase and risk surface. It figures out which vulnerabilities actually matter in your specific context and filters out the noise. This adaptive feedback is absolutely crucial because it prevents the alert fatigue that so often causes developers to just start ignoring security warnings altogether. Section 5, Multi-Agent Orchestration, the Network Effect.
So individual agents, fixing tests or scanning code? Awesome. But the real magic, the real paradigm shift, happens when we introduce orchestration. In a modern pipeline, you don't just have one agent, you have an entire network. A build agent validating outputs, a test agent managing the release gates, a deployment agent handling rollouts, a monitor agent watching production. And crucially, they do not work in silos. They actively pass contextual information back and forth. The test agent might tell the deployment agent, hey, this specific module was a little tricky in staging. Keep a really close eye on it during the rollout.
How do all these agents actually talk to each other and your tools? Through standards like the Model Context Protocol, or MCP. This is the critical modular building block. It allows agents to interact with external systems without needing some clunky custom integration built for every single touchpoint. It's what allows this whole multi-agent network to successfully scale across a massive enterprise architecture.
Section 6, the autonomous DevOps mindset, a structural shift. All right, we have covered a ton of ground today, but the technology is honestly only half the battle. There's a quote from the source material that sums it up perfectly. The pipeline itself becomes an active part of the problem-solving process. Agentic AI isn't just a feature you toggle on. It's an intelligent entity striving to get the job done. It fundamentally shifts your pipeline from a passive conveyor belt that just halts when a box falls off to an active robotic arm that picks the box back up, fixes it, and keeps the line moving. But none of this is plug and play. It takes serious architectural investment and a willingness to let go of our old deterministic safety blankets. So I'll leave you with this question to think about. Is your team ready to invest in the architecture of autonomy so you can ship software faster? Or are you going to keep waking up at 3 a.m. to fix CSS selectors? Thanks so much for hanging out and learning with me today, and I will catch you on the next explainer.